Our next topic is protein energy malnutrition. This is a condition arising due to malnutrition. Malnutrition means lack of sufficient nutrients in the body, or it occurs when the body doesn't get enough nutrients. And the causes may include a poor diet, digestive conditions, or any other disease. So protein energy malnutrition is a form of malnutrition arising from lack of proteins or carbohydrates in diet in varying proportions. So the condition has mild, moderate and severe effects on the body. So if sufficient diet with sufficient proteins and carbohydrates is not reaching our body, it results in a condition called protein energy malnutrition. Protein energy malnutrition refers to the disorders arising from dietary deficiencies of proteins and total food calories. So calories is the content of energy present in the food. It is common among children in underdeveloped and developing countries. So where the people are not getting enough nutrient-rich food materials, and maybe in parts of the countries like Africa, Asia, Southern Europe and Southern America, we find mostly this condition arises due to deficiency of proteins, carbohydrates and fats, mainly these energy-giving foods or nutrients in the food item, which results in various types of disorders or conditions which affect the total health of the society. It may affect large sections of population during drought, famine or political turmoil, that is during the time of war. Countries are not able to provide enough food, or there will be scarcity of food, which results in such disorders. So during drought conditions, there is scarcity of food, agriculture production is not possible. Then it affects children in the age group 1 to 5 years. And the children retain weight and are susceptible to infections. And in many countries, nearly half the children do not survive due to the age of 5 years due to protein energy malnutrition. And kwashiorkor and marasmus are the two common diseases due to PEM. So we have to study about these two diseases in detail. So first PEM is marasmus. It arises due to dietary deficiencies of both proteins and carbohydrates when the mother's milk is replaced too early by other low protein and energy foods. Common in infants less than a year of age, and this happens if the mother has second pregnancy and childbirth when the older infant is still too young. So this happens when there is undernourishment of both proteins and carbohydrates or total food calories, and it is common in children below 1 year of age due to inadequate diet and less spacing of children and replacement of mother's milk with calorie deficient food. So this is the reason for marasmus. The symptoms of marasmus are it impairs growth and replacement of tissue proteins. So growth and development will be affected. Emaciation of the body, that is, emaciation means state of being abnormally thin or weak. There is extreme weight loss due to loss of fat under skin or muscles throughout the body. Such condition is called emaciation. Then thinning of limbs. Limbs become very thin and person becomes weak. Skin becomes dry, thin and wrinkled due to loss of fat from the skin. Skin becomes dry, thin and wrinkled. So these are the few symptoms where complete growth and replacement of the tissue proteins are also affected. Weakness, thinning of limbs and skin becomes dry. And other symptoms are growth rate and body weight declines, the growth and development of brain and retarded mental growth. So it leads to retarded both physical and mental growth. And there is frequent diarrhea. That is, the child suffers from repeated diarrhea, digestive disorders due to the problems with the digestive glands, and it results in frequent diarrhea. The fat under the skin is deficient, so as a result the bones become prominent or the ribs become prominent. The fat under the skin will be used up, as the stored fat will be used up when there is insufficient protein in the carbohydrates in the food. So body will be using the stored fat. So slowly the skin becomes dry, wrinkled, and ribs and the other bones become prominent. Now we'll see the prevention of marasmus. So marasmus can be controlled by giving the child a diet rich in both animal proteins and plant proteins. So the diet should have a combination of wheat, gram, peanuts, soybean, as well as it should also contain animal proteins like mutton, chicken and fish, from which they will get enough proteins. Then it is important to educate people about the significance of spacing the birth of children. Spacing means the time period between the birth of two children, and the importance of breastfeeding. So there should be enough time between two children so that the mother can take care of the child and ensure proper protein rich diet for the child. So it is better for both health. Next disease due to protein energy malnutrition is kwashiorkor. Kwashiorkor, it is a serious protein deficiency disease, and it is prevalent among babies and young children aged 1 to 3 years, and caused by deficiency of protein with or without deficiency of carbohydrate, and by severe protein deficiency in the diet leads to kwashiorkor. And if not treated early, more than half of the children suffering from kwashiorkor die. So in this condition, the child shows retarded growth. Both the mental and physical development is affected. And the characteristic feature is the stomach protrudes out due to edema. The symptoms of kwashiorkor. The first one is wasting of muscles. So the thin upper arms, though some fat may be still left under the skin, it has a lean appearance. So the muscles become thin. And thinning of the limbs. Limbs also become very thin. Then edema. Edema is water retention. So as a result of retaining water in the body tissues, that body parts become swollen, and swelling of the body parts. So it begins with weight loss and later leads to edema, that is water retention. There is swelling of hands, feet and face shows bulging eyes. So these are some characteristic features caused due to or by kwashiorkor. Other symptoms are protruded belly. The child has distended belly, that is stomach protrudes out. Then skin pigmentation. Skin becomes dark and irregularly pigmented and may peel off at places, likely to develop skin inflammation about the mouth and eyes. Retarded growth. The child shows emaciated appearance, retarded growth of the body and brain, and is emotionally depressed. Last one is fat is normal. So the fat under the skin is, even though it is lost, some fat may be still left under the skin, not as just like the other disease called marasmus. So these are the symptoms of kwashiorkor. So protruded belly due to edema, then skin pigmentation, retarded growth, fat. Next is prevention. How we can prevent this? Giving protein-rich diet. So milk and egg should be included in the diet. So for babies and young children, the most important dietary treatment is to give lots of milk and eggs. Vegetable sources of protein like soya bean and animal proteins also should be included. That is wheat, peanut, soya bean, jaggery, and chicken, meat. All this should be included properly in the diet. And the child needs to be treated early and properly. So this disease can be cured by giving protein-rich diet. So if we are giving regularly protein-rich diet, we can keep away from this disease. And all the sources of protein, which is plant protein and animal protein, in a proper amount should be given. So here you can see children affected with kwashiorkor and marasmus. So what all symptoms we studied, you can observe here a few symptoms. The belly is protruded, stomach is protruding out. You can see the ribs, they have become prominent. The muscles are not well developed, that is muscles are lean, and limbs, hands and legs, they have become very thin and lean. And fat layer under the skin is not enough, so that skin is very dry and wrinkled appearance. So you can see the features of this protein energy malnutrition in these children. So our next and the last topic in this chapter is calorific value of food. Let us see what is calorific value of food. So our body needs energy for survival and to perform all body functions. This energy is obtained from the food that we eat. So the energy requirement of various individuals differ due to sex or age or body size or activity or even temperature of the external environment. So accordingly, the energy requirements varies from individual to individual. Now the main foods from which we get energy, they are the carbohydrates, proteins and fats. So the energy content of the food is expressed in the form of heat energy present in the food. That is, when the food breaks down, that much energy, what is the energy which we are getting? And that energy is expressed in the form of, in terms of heat energy. And it is measured to as calorie, or it is referred to as calorie. The amount of heat energy produced from the oxidation or breaking down of the particular nutrient, which we call it as calorie, or the energy present in the chemical bonds inside that molecule. So that is called calorie. So a calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. That is the standard definition for a calorie. So a calorie, the energy content of food is measured in the form of heat energy present in the food, and it is often measured in calories. So we can define a calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. That is called a calorie. Now, since this value, it is very small and the term kilocalorie or kilojoules is often used. So this calorie is very small. So instead of that, what is used is kilocalorie or kilojoules is used. So the 1 kilocalorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 kilogram of water by 1 degree Celsius. So since this calorie is very small or tiny, the kilocalorie is replaced, and it is the amount of heat energy required to raise the temperature of 1 kilogram of water by 1 degree Celsius. So calorific value of food is given in kilocalorie per gram. So if you are buying certain products from the market, on the outside you can see it is written the calorific value of food. You just check it when you are getting, you can see what is the calorific value of particular nutrient in that particular food item. So it will be given in kilocalorie per gram. Carbohydrates, it will be given there. In that way it will be given in that particular quantity. So when we refer to calorific value of food, it is normally referred as kilocalorie per gram. Then gross calorific value and physiologic calorific value. When you hear the terms, you feel a little bit complicated. Nothing is there. Gross calorific value. It is a amount of heat energy. So it is an amount of heat energy liberated from complete combustion of food in a bomb calorimeter in the laboratory. So if you are completely oxidizing or completely burning up a particular food item in the laboratory in a closed condition, it is a bomb calorimeter, it is a closed chamber where there is no escape of heat. So complete closed chamber, the amount of heat energy liberated in such a closed chamber in a laboratory, we call it gross calorific value. And what is physiological calorific value? It is the amount of heat energy liberated by complete oxidation of 1 gram of food in our body. So what is happening in our body? The amount of heat energy liberated by that particular nutrient, we call it physiological calorific value. And what is done in the laboratory in artificial conditions, closed chamber, the combustion of or burning of that particular nutrient, breaking down of that nutrient, what is the energy released? That is called the gross calorific value. Now the point to be noted here is that always this physiological calorific value will be less than gross calorific value. That is, this physiological calorific value, it is happening or it is produced inside our body. So we know what is produced inside our body. As a result of that reaction, various intermediate products are also released, and also the energy is lost in one or the other way. But in a bomb calorimeter, there is no loss of energy. It is a completely closed chamber. So we can say physiological calorific value, it will be always little bit slightly less than the gross calorific value. Then complete combustion of nutrients in the laboratory and the oxidation of the same in the body slightly differ, as some energy is lost in the formation of intermediate products in the body. So physiological calorific value will be less than gross calorific value. So we can compare certain calorific values of certain nutrients here. Gross calorific value of carbohydrate is 4.1 kilocalorie. You can see physiological calorific value of carbohydrate is 4 kilocalories. So little bit less than the gross. Then proteins, you can see gross calorific value is 5.6 kilocalorie, where in the case of proteins, of this physiological value of proteins is 4 kilocalorie. Then fats, gross calorific value of fats is 9.4 kilocalorie per gram. Comparing with the physiological value, it is 9 kilocalorie per gram. So slightly less than the gross calorie. So in this way, it is different in artificial conditions, and also it is different in the body. So in this way, we completed this chapter. And you have to, I hope all of you got your textbooks. So go through your textbooks and try to find out the answers for the questions which you have not written till now. And complete the notes, and one by one I'll be asking you to submit the notes for checking. So I should not get any notes which is not completed. So all of you try to complete it as fast as possible and make it thorough. So this last topic, this calorific value, actually in your textbook it is given which is not to be evaluated, for your general information, but you should know about that. Okay? Thank you. We'll meet in the next class.